So the first part of this is pretty easy. Positive velocity is when an object would be moving forward. And so when you read this graph, you're looking for the places of the line that are above the x-axis. So that would be like here and here, right? You'd be looking at the time that. So basically, the way you designate this is that for 0 less than or equal to t less than or equal to 1 second, you'd be above the x-axis, right? And then between 5 less than or equal to t less than or equal to 7 seconds, you'd be above the x-axis again. And then to move backwards, you're looking for a negative velocity, right? So you're looking for the opposite. And the only time that's under the x-axis is between time 1, right? It drops below, and it actually stays below all the way until 5 seconds. Now the second part, when they ask about speeding up, if you look in the second box, right, it says that if velocity and acceleration both have the same positive or negative sign, the object is getting faster. Now in a velocity graph, the acceleration is the slope of this graph. So what we're looking for is the places where you're either above the x-axis and rising, right? So that happens between time 5 and 6, right? You have this upward piece right here, right? Or if you're below the x-axis, you want to be decreasing, which would be true here. So the other answer would be between 1 and 2 seconds, right? And then to slow down, so these would be speeding up, right? And then slowing down is the opposite. You want the ones that are above the x-axis to be decreasing. So between 0 and 1 second, we have that, right? And we have it from 6 to 7 seconds, where we are above the x-axis but decreasing. And then also underneath, when in between 3 to 5 seconds, right, we are we have a negative velocity but a positive acceleration. And so our speed is getting closer and closer to 0. Okay, and that finishes part A. It's pretty long, right? For part B, when is the accelerations positive? Well, we just talked about that. So positive acceleration on the velocity graph, right, would be rising portions of the graph, right? So we see that basically the only place where that's true would be between 3 and 6 seconds, right? Negative acceleration would be the opposite, where the graph is falling, and so that happens between 0 and 2 seconds, right? You can see on this line all the way from here to here, and then it also happens again between 6 and 7 seconds. And then the acceleration is equal to 0 if we have a flat line on the velocity graph, so that's between 2 to 3 seconds, and from 7 to 9 seconds. In part C, they ask us when is the particle moving at its greatest speed, and since it's a velocity graph, we want to know where is the y-coordinate the highest. Right, because the y-coordinates are giving the values of the velocity. Y-coordinate, right, and that would occur right here, right, at t equals 0. Seconds, And then in part D, when does the particle stand still for more than an instant? Well, so we need to look at this, right? When velocity is equal to 0, the object is stationary or changing direction. And so at t equals 1 seconds, it hits a place where the velocity goes to 0, but that's only momentary. And so the only places that we're looking at are the interval between 7 and 9 seconds, right? So we want v equal to 0 for 7 to 9 seconds.